Uh, Hello everyone. I want to start with welcoming you guys to Laboratory 1 course. This course is about workshop and manufacturing. Basically what we are going to be doing in this class is that we're going to give you some theoretical backgrounds first in first weeks, and after that in later weeks we're going to go to the lab and we're going to do some real life applications there, okay? Here I want to say we're going to share all these slides for you to read and study, okay? So do not worry about the slides, we're going to share them. Here this is vehicle subjects, but however we're going to change it and we're going to share it with you. We're going to make a new one. Course learning outcomes. So in this course, you're going to learn how to measure some dimensions with some measuring instruments like micrometer, Vernier caliper, and etc. Also, you're going to be learning about manufacture techniques. You're going to learn about some manufacture techniques, and you're going to apply some of them. This is our evaluation system. You can see the percentages, but however, those percentages can vary, okay? So be aware of it. Homeworks, about homeworks, I can say, like, please submit your homeworks in time. Otherwise, your points going to be deducted and you don't want that. We don't want that, okay? Be careful about it. About course announcements, we're going to be making our announcements with Google Classroom. We have a total of 8 groups, okay? And each group's going to be each group's going to be have its own Google Classroom, and we're going to share some. We're going to share the Google Classroom code with you, so you can join. Okay. It is important because like those presentations going to be shared with Google Classroom. Your homework is going to be assigned with Google Classroom, so you must be a member of it. Please be a member of it. It's important. Application parts, we're going to talk about it later. Here, this is our laboratory equipment. You're going to see them in our laboratory too. And work safety. About work safety, I can say that we are going to go to laboratory together, and you're going to need to use some equipments there. Okay. But before using them, please learn how to use them first. It is going to be safer for us. So please be aware of it. These are some general rules. Please read them. I'm just going to skip them now. Here I can mention this one. This is called emergency stop button. So basically what it does is when you're pressing it, after you press it, immediately it stops the machine. So it is important for safety. It is good to know. Before starting a machine, check that the machine guards are in place. Okay, they have been put there for your safety, so be aware of it. These are types of fires. I'm just going to skip them now. The actions to be taken in case of injury. Those are some numbers that you can call, that you can use in case of injury. So it is good to know them. Yeah, just know. Now about manufacturing technologies. So what is manufacturing? We engineers, we design some mechanical parts to satisfy some needs, right? But first you're using mathematics, you're using physics, and you're using, let's say, some designing tools, designing software applications, and let's say you design a gearbox. And after that, you want to take the product. You want to produce this part so you can apply it, right? So you're going to have some set of manufacturing processes, and after that you're going to govern this shape. But this is called manufacturing. And we're going to have, we have 4 videos, which are some examples of manufacturing processes. And let's start with the first one. And by the way, in these slides, there are going to be some videos, and we're going to share those videos with you too. And to watch them is going to be your homework. But together here, I'm going to show you some important parts. Okay, here the first one. So you have your metal sheets here. You're placing it to a furnace to heat it. Why do I heat my metal sheet? Because when you heat your material, it gets softened, and when it gets softened, it is easier to shape. So this is why we are heating. And after that, here you're placing it to here. Here on the bottom, this is called mold, and this is your heated sheet metal. So what you're doing here is to press your sheet into the mold, and therefore you're going to have your sheet metal to be formed. This is video 2. Let's watch this one. So this is a drilling machine. Basically what a drill machine does is it drills holes. Okay. So this is called tapping here. What is for tapping? What is tapping for? So these holes are for your screws, right? You're going to insert some screws into these holes. To ease the screwing process, you're using tapping. So there you go. Third one, sieving machine. I'm just going to skip this one. And machinery. We're going to be talking a lot about machinery in this course. Here, this one is just for introduction. So this is your machine. So there's a concept in this machine which is called number of axes. This machine here has total of 5 axes. But how do we count them? So you have your machine here. It can go to this axis. This is axis 1. It can also go to in this axis. So it makes 2. It can go to this axis. It makes 3. Here in the bed, it can make the movements of this, right? This is your 4th axis, and also here the part can spin around, and this is your 5th axis. So it makes total of 5. Manufacturing processes. So we have our manufacturing processes, right? And some people categorize them so that we can understand them better. Okay. And here we have total of 6 categories. For example, in third one here, this is machining. This is machining category, and you have turning, boring, drilling, and milling processes. Okay. Casting processes category. This is the first category. You have the branches of it. And here we have video 5. Let's watch it together. So this is going to be your mold later. Here you're hitting the mold, and the liquid starts dropping. Here, this is called your mold. Okay? This is mold. Into your mold, you're pouring some hot metal, hot liquid metal, and this process here is called casting. You're filling your mold with metal, and you're letting it to cool. And after that, with some vibration, all you left with is your desired metal machine parts. Sand casting. Let's watch this one. So this is your shape. You're pouring some sand into it, and you're pressing this sand to get more compact. And there we go. Now this is going to be your mold, right? And after that, you're going to pour the liquid, which is casting, and you're going to let it cool. And after that, what you're going to be left with is your machine parts, your material. Here, this is a real life casting video. So yeah, here this is your mold, and this is your aluminum, liquid aluminum, which is really hot. You're just pouring it into the mold, which is casting. And after that, you're just removing, you're just opening your mold. And what you're left with is your machine part. Another category, bulk deformation. Let's watch this one. So you have a bulk of raw material. You're just pressing it, and it takes the shape of the mold. This is 8-1. This is video 9. Let's watch this one too. So this is your unshaped solid. So what you're doing is you're feeding your unshaped solid in that way, and also you're turning your turning machine in that way and that way, and there you go. It takes the shape that is desired. Okay, another category, which is called sheet metal forming. Let's watch video number 10.
like ordinary hand shears. It is known as the blade or essential. They
So this is your sheet metal. And
partially penetrate the material.
to apart the metal into two, to cut it, you're going to apply some force. And this force here is called shear
Builds up
force.
opposing forces in the stock. A crack or tear called
This is called,
the slip,
therefore, metal shear. And here you can,
yield point, just as in not past its ultimate tensile strength, which is the metal's ability to resist tearing.
it is called metal
The
bending.
forces apply
Because you're applying some bending force to it, and it bends. Okay. All right. Another video. This one is a little interesting. So basically, you have a metal sheet here, and you're spinning it with high speed with your turning machine. And the part on the right is your this is your mold, right? All right, this is your mold, and you're pressing your sheet material into your mold while it's turning, and it takes the shape. There you go. This one is not really important for us for now, so I'm just going to skip it. And here, machining and finishing processes. This one here is a lot important for us. Video 12. That's sponsored.
in straight turning. The tool is fed parallel to the axis of the work to reduce its diameter so that the final diameter is the same at each end.
So this is straight turning, what he says. So
removing a significant amount of material in one pass is called rough turning.
So you're going to have a rough turning.
Lighter cut that creates a smooth surface finish is called finish turning.
And finish turning. So you're going to take a good amount of diameter thickness with rough turning, and after that you're going to use your
finish is called finish turning. Taper turning produces a taper along the axis of the workpiece. Tapers are produced by offsetting the tailstock from center line or by using a taper attachment. Short, steep tapers can be turned using a compound rest. Contour turning.
This is contour turning, which is important for us. Basically, it helps to
profiling was formerly performed by having the single-point cutting tool trace a template of the desired profile shape. This has largely been replaced by CNC turning, in which the desired contour is simply programmed into the machine, which directs a cutting tool to cut the contour. Forming is another alternative for generating complicated shapes. The tool having the desired form or geometry is advanced perpendicular to the axis of rotation, reproducing the tool shape in the workpiece. Forming is commonly performed on automatic.
By the way, those liquids are cooling liquids because these forces here are really big, because you're cutting a material, you're shaping a hard material, so the forces are really big and the heat is pretty big. Therefore, you have to use some cooling liquid. This is your cooling liquids.
Chamfering eliminates sharp corners from a workpiece and is a good safety measure. Typically, chamfering breaks corners at a 45-degree angle. Grooving creates a groove or recess using a tool that is usually the size and shape of the required groove. Some grooving tools can also widen a groove by traversing side to side after plunging into the workpiece.
There you go, this is turning and milling. Let's watch this one too.
Drive keys and a retaining bolt. Carbide inserts are secured to the cutter with screws. A face mill with positive axial rake reduces cutting forces and vibration. The milling head should be positioned close to the workpiece to minimize quill extension and maximize rigidity. Locking the gibs on the Y and Z axes will further improve rigidity. Steel and brass materials can be cut dry, while aluminum, stainless steel, and titanium should be cut with an appropriate lubricant or coolant. The FM45 indexable face mill shown here is manufactured by Glasern Machine Tools and uses square inserts tilted at 45 degrees. Each insert has 4 cutting edges and can be rotated 90 degrees to expose a fresh cutting
This is
edge.
face milling.
WD-40 serves as an ventilation speed at a shallower depth of cut.
So this is your finishing pass. Like,
Regular inserts, such as but are capable of milling shoulders and slots.
let's watch video 2. We have one more video for milling.
Boring operation. These end mills create a rough texture on the workpiece. A standard end mill can be used for roughing as well as finishing.
So remember, in the previous video, you didn't have these ones, the side cutters, but here you have your side cutters too.
This extra long high-speed steel end mill has 4 spiral flutes. A similar end mill with 2 flutes is recommended on manual machines. Feeding the workpiece in the same direction as the cutter rotation is known as climb milling. The heat-resistant coating can improve cutter life. Cutting a pocket begins by ramping the end mill into the workpiece. Ramping is recommended over plunging due to the improved evacuation of chips. Chip removal is also facilitated with the use of compressed air.
Here, those things are called chips, by the way, and those things are really hot. So you would want to avoid a skin touch with them. It can cause some serious injuries with your eye. Well, let's say those chips, one of those chips, it go through your eye. Since it is really hot, you can almost go blind with it. So you have to be careful about it. You have to wear your eyeglasses, your glasses, protection glasses.
Helical boring can be used to machine aluminum, a hard mended for cutting aluminum. Power than solid carbide.
Okay, this is milling and laser machining. Let's watch this one. So you have your sheet metal. With help of laser, you're just cutting. Of course, it has its advantages and disadvantages. But generally, these things are cheaper than the other ones. But it can deflect your material, which is a disadvantage. And water jet machining. If you haven't seen one of these before, these are really interesting things, interesting machines, because you're just using some waters, like But this welder is highly pressurized and it can cut your metal like a bread. Like this is an element probably, but just with water you can cut it. Pretty cool. Here another category which is called joining processes. Here you can see some branches of it. It is also important for us too. So let's watch the video.
The type of welding is defined by how the filler metal is fed into the welding process. There are two types of welding, wire feed welding and stick welding. Wire feed welding uses a gun to feed the wire into the welding area. Two types of guns may be used for wire feed welding: standard guns and spool guns. A standard gun uses wire housed inside the machine and fed through a cable. A spool gun uses wire housed on the gun itself.
So you see you have a filler element and you're filling your cavity with it, which is a metal probably. And those two parts are assembled.
When the gun trigger is pulled, an arc is created at the tip of the gun between the wire and the metal to be joined. The wire melts to fill the joint.
So this is the wire and it melts with fission.
Pulling the trigger releases more wire into the welding area. The type of wire determines the welding machine setup. When solid wire is used, shielding gas from a gas cylinder connected to the machine is needed to protect the weld. This is also known as MIG welding. When flux cord wire is used, a chemical inside the wire provides the shielding, so no additional gas is needed. Besides wire feed welding, the other type of welding is called stick welding. Stick welding doesn't use a gun. It uses a stick electrode placed in an electrode holder. The arc is created between the stick electrode and the metal.
This is called arc.
The electrode melts as it's fed into the weld area. No additional shielding gas is used when stick welding. The stick electrodes are
But these are fillers, okay? You're melting these.
coated with chemicals that are released when melted to create the shield.
Okay. This one is interesting too. So there are some other welding methods, this is one of them.
Motion and pressure are converted into.
So basically what we're doing here is this part and this part are not combined at the moment. I think this one is stationary, yeah. This one is stationary and this one is rotating. And with friction, they are welded together. This one is rotating and this one is feeding into the rotating elements. See? Okay. This one is spinning with a high speed and you're feeding the metal on the right to the left. And there you go. You're welded. They are welded now. One more welding type, which is resistance welding. So basically what happens here is that there are some electrons go through in this section and there are some heats generated with this action. And therefore they're going to be joined together. They're going to be welded. There you can see. Electrons go through and they're going to be welded together. I'm going to skip this one. You can watch it. So here, selection of manufacturing processes. So how do we select our manufacturing processes to form a raw material into a desired machine part? So of course, it is going to be depending on geometry of your desired part, right? Also, your tolerances are going to be important. Also, material features are going to be important for selecting it. Let's say, like, for example, there are some materials, like a material are either ductile or brittle. So the brittle materials are easy to machine, like it is easy to milling them, or using a turning machine for brittle material is easy. But for ductile materials, you cannot use milling machines. It will cause some bad features into them. So this is an example of selecting manufacturing process. So if your material is brittle, if it's hard, you can use milling machines. You can use machining processes. Selecting your manufacturing process should also like minimize your cost, right? You would want to be cost efficient. For example, like remember the metal sheets cutting. If you can use laser cutters for sheet metal cutting, it would be cheaper for you. But remember, those laser cutters could have some like downsides, like it can deflect your material a little bit. So you have to decide. You have to decide according to it. I'm going to skip this one. Please read them. So, selection of materials. Like as I said before, of course, the selection of the materials are pretty important because some materials are easy to cast and some materials are easier to machine. Okay, like here you can see on the table, you have some various of materials here, and these are your machinability, weldability, and castability. So basically, let's see aluminum. Let's examine aluminum because we use aluminum a lot. So aluminum is a brittle material. Okay, it is not so hard, but it's brittle. So it is easy to machine aluminum. It is also easy to cast it. Like castability is really high. However, weldability is not that good, but it is fair. On the other hand, let's see white cast iron. So white cast iron is really a really hard material. It's really hard. So that's why it is not easy to machine it. Like you can see, it says VP. It's very poor. Since the material is really hard, it is not easy to cut the material. Like machinability is really poor. But castability is not that bad because it's in the name, it's cast iron, so its castability is really high. So knowing what material you're using is important to select your manufacturing process. I'm going to skip this one. And CIM. So CIM is called computer integrated manufacturing. Why do we use computers? Because they are more precise, because they are easing our job. We have CNCs, which you're going to see those a lot. in factories. So here, this is CNC, for example. Here is a video. We can watch this one a little bit. See, you have your parts and you have your robot arm, and your robot arm places the part into the machine. And maybe after that, after this machine finishes its job, probably the robot going to place that material into this one. It put this one. It is ready to go. Okay. I'm going to leave it to you to watch this ones. So let's watch this one too. This is our last video, by the way. So you see there's a circuit board here, and these circuit boards are pretty little. So you cannot do such sensitive movements with your bare hands. Your hand is not that precise, but the robot could be really precise. So that's why we are using it. And that's all. Okay, your first assignment is to watch all those videos here that is showing. And this is going to be your homework for this week. See you in the next video.